So my name is Sundar. I am the VP of Products at Cisco AppDynamics. And what we're going to talk about today for the next 30 minutes or so is about cloud native observability. And for those of you who missed it, we launched a product yesterday called AppDynamics Cloud as part of the Cisco Live keynote. And we'll talk a little bit more about that product, what the capabilities are, what are the initial set of features that we're delivering to the market, how we think about the entire vision for this product. All right. So why are we doing what we're doing? Right? We all know this. Like, this has been our reality for the last decade or so. Applications are the new business, right? And as applications kind of spread out across multiple areas, all the way from on-prem to cloud, they have multiple elements. But the more important thing is the front-end experience, whether it is a mobile experience, whether it is a desktop experience, whether it is a web experience, is effectively the business outcome right now, right? Poor experience impacts business outcomes. So experience optimization is absolutely critical, right, for all of our users and customers. So what do we need to do as IT ops folks, as DevOps folks, as SRE folks, as app owners? We have to realize that today, modern applications are multi-cloud. Again, this is not new. This has been our reality. And depending upon the organization that we are in, they are at various stages of the maturity curve, right? Some of them are still very much focused on kind of on-prem data centers. There are many of them which are born in the cloud, right? They only deploy cloud-native applications, whether they're using AWS, whether they're using Azure, whether they're using GCP, or they have their own kind of regional clouds, right? Modern applications, by definition, have become hybrid and multi-cloud. And so what that means is as follows, right? In order for us to focus on experience optimization, in order for us to get an end-to-end view and ensure that we deliver a full experience for our users, and at the periods of time when we don't, right? When that shopping cart fails, when that particular trading app actually stops, we want to be able to know about it literally within seconds and be able to remediate that, right? That's the problem that we are trying to solve with full stack observability. So in Cisco, we have a view, right? We have a view that if you look at full stack observability, it goes all the way from the experience, the end user experience, but you need to be able to deep dive into the actual business context. And as you look at it, you are able to correlate issues, areas, performance from application, infrastructure, security, all the way down into the data layer. And the best part is we need to do this across private clouds, public clouds, on-prem and managed data centers, right? Giving that kind of a full stack observability view is the only way that we can focus on experience optimization for our users. So if you think about that as the problem we are trying to solve, we have defined a set of use cases that we think every organization needs to think about when they think about their full stack observability, right? We think about it in three broad pillars. Pillar number one is around performance. Pillar number two is around optimization. Pillar number three is about security. And the way to think about it is reasonably simple, right? How do we observe, monitor the performance of the set of applications and the entire technology end-to-end stack, the entire end-to-end view? Once, if we discover issues, if we discover suboptimality, how do we optimize it, both from a cost as well as from a performance perspective? And lastly, how do we do all of this in a secure fashion, right? That's really the genesis of why we think that these are the kind of the key pillars for full stack observability. And within each of this, within performance, hybrid application monitoring, and modern cloud native app monitoring, these are the areas that we will talk about in the next few minutes and go deeper. But you also think broadly of this idea of how do we think about customers' digital experience and how do we correlate that to the backend server applications, right? How do we give that end-to-end view to users such that they can make decisions based on the actual business outcomes? Lastly, app dependency monitoring obviously is critical in order for us to deliver this. In the optimization bucket, as I mentioned, it's all about kind of hybrid cost optimization and really resource optimization in order to kind of feed these use cases. And lastly, in terms of app security, which you will hear in a few more sessions. All right, today we're going to talk, as I said, in the next few minutes, much more about hybrid application monitoring and the modern cloud native application monitoring. So why? Let's start with, again, the why, right? Why are we focusing on this particular area? Our industry has been in a unique place, right? The problem with cloud observability today is it looks like that building, right? It's a bunch of existing tools that have been developed over the last decade or so, where a single purpose use case has kind of been smushed on to various different bolted on use cases. As a result, it looks like that building. And what does this mean, right? for a DevOps person or for an SRE or a cloud ops person, it's resulted in what we call the swivel chair phenomenon. There are lots of different point tools or different parts of an existing point tool, and there are disconnected data silos. So what they're forced to do is to either go from tool to tool to tool or from tab to tab to tab in a given tool. It makes finding the root cause extremely challenging, right? More importantly, they also get incomplete visibility. It becomes like, it's not my problem, right? It's not the network issue, it's not the storage issue, it's not the app issue, it's not just at the business layer. But getting an end-to-end view becomes a challenge. And last but not the least, each, whether it is vendor solutions or it's open source technologies, it's a biased point of view, depending upon where they started. It's a log-centric view or a trace-centric view or an infrastructure-centric view. But seeing that end-to-end view is seriously missing. And when we go out and talk to customers, the biggest thing that they say is two problems, right? One, help me get one single view or one single language by which I can bring the different personas in my organization to a shared understanding. If we do that, that alone reduces the RCA very significantly, right? That literally is the problem that we are solving with AppDynamics Cloud, right? When we think about it, we think about that AppDynamics Cloud allows us a basis by which we can solve this problem, because it's based on this full stack observability vision that we have laid out. But more importantly, it's focused on cloud native applications, and it has that end-to-end view that we spoke about, right? So in the next few minutes, I'm going to deep dive into some of the capabilities that AppDynamics Cloud is bringing, and also some of the platform approach that we're using for AppDynamics Cloud. In addition, I'll also show you a demo. So I'll tell you what I'm going to show you, and then I will show you, and then we can keep going. All right, so in terms of how we have thought about this product, given the problem that we are describing, there are a few fundamental design principles that we had to imbibe while we were building this product. The first one is, hey, a cloud-native observability requires a different approach, right? You cannot take an existing product and just tack on cloud-native observability on it. That was kind of big aha learning number one, right? Don't build that smushed up building that I kind of showed. So what that meant was we had to build a data platform and a data model which allowed us to bring input from data across the stack, all the way from business down into the infrastructure, and be able to do cross-domain insights, right? Cross-domain visualization and insights. Second, we needed to not just be able to collect data from proprietary agents, but we needed to build an open telemetry platform and open telemetry compliant APIs so that any application out there which is instrumented with open telemetry will be able to send data in there. Right? Third, of course, you are observing cloud native applications. You need cloud native scalable platform, right? But more importantly, what we have thought about is building an extensible platform so that it's not just us building solutions on top. It makes us easy for the rest of the Cisco and AppDynamics to do this together so that you get the larger Cisco story, right? But more importantly, it also opens it up to citizen developers over a span of time so that partners can build solutions, right? And last but not the least, this idea of observability needs to be in the context of business so that when you get that alert at 2 a.m., you know whether you need to get up and resolve it because it has an impact on ARR versus, you know what, that problem will get fixed and I can take care of it after my morning coffee at 8 a.m. That is an important decision point in our industry when users get those alerts, right? We have always traditionally focused on being able to contextualize this in business impact, and that's an area that we'll kind of continues to focus on. Business impact-based troubleshooting is a big area that we think the industry needs in some ways, and we're leading the way. Cool. So as we think about it, when you think about what it means to simplify cloud-native complexity, right? 3 key pillars. First one, as I mentioned, is this idea of cross-domain insights. And why is this important, right? If you're able to contextualize, when you, let's say a network operations person sees that there is a network alert. If that person has the ability to understand what is the business impact, they're an e-commerce company, if it has an impact on shopping cart drops, then it is a critical thing that they need to go react to, and they need to let other teams know about what that view is. The NetOps person does not have the entire view, but if you can arm them with the end-to-end view that they are able to get what is the impact of default in their domain and how does it impact others, then it's extremely critical. More importantly, the users are thirsty for, in some ways, almost proactive and predictive alerting, right? They want to be able to know, hey, if this shared service is having an issue, what is going to be the impact for some other higher layer? Today, we do not really offer that view. And that's one area that using cross-domain insights, we'll be able to build on future so that we can give them clues. We can effectively allow them to understand what could be the implication of the faults in one domain and how does it impact somewhere else, right? So that's what cross-domain insights is about. And that's a key value prop even for our first release. Second one is around cross-melt troubleshooting. Again, same kind of deal. Today, very, very clearly, right? You go into a logs tool and you get a whole bunch of insights about what logs data provides you in terms of where a fault could be or where there's an issue. However, it's not correlated to what the specific entities are, what are the specific services that are emitting this, and more importantly, when this service has an impact, what is the underlying infrastructure that's causing this? Right? So you could make the exact same argument for a metrics-based view or a traces-based view. The ability to bring all of these allows users to, one, get a very opinionated view of their entire troubleshooting journey. Two, it allows them ability to ask questions across each of these data types in order to be able to power their troubleshooting, right? And go faster in terms of root cause analysis. So that's what cross-melt troubleshooting is about. And when you see the demo, you'll see examples of where we are bringing metrics, logs, and events data together in order to help with the troubleshooting. The last one, of course, as an industry, we all have been working towards ensuring that there is more and more AI in the system so that the amount of human configuration is reduced, the amount of human attempts or manual attempts at putting together and solving problems gets reduced, right? We want AI to help us in things like anomaly detection so that we don't have to set up bulky health rules, set up manual configurations, so on and so forth. The key really is really helping humans go faster with AI ops, right? That's what AI-assisted RCA is all about. And what that leads to is faster MTTR and faster MTTD. That's kind of the genesis for why we think about AI-assisted RCA. Another area that we specifically focus on is this idea of being able to tune the AI algorithms for the users in production. One thing that we found out when we started building this product is tons of applications, their profile of what they would call as noisy versus something which they need time sensitivity was very, very different. And you could go ask the humans, the operators, about what's the nature of their applications, they would not know. What you needed is a set of learning algorithms out there in the market where users could give feedback on the effectiveness of the anomaly detection or pattern detection algorithms that are out there. And based on that feedback, the algorithms get tuned. So it starts super simple, right? We're starting off with a very simple idea of where there's a set of anomalies that are being exposed to the end users. Users can do a simple thumbs up and thumbs down and give an explanation for whether the alert was the right amount, was it too noisy, or was it time sensitive. And that alone helps kind of tune the algorithm in production so that the customers and users can personalize it to their environments. And that makes it really, really powerful and increases the adoption of the AI within the systems. Right? So let me dive into each of this a little bit, then we'll get to the demo. So in terms of a cross-domain insights, so let me walk through kind of the picture that you see on the deck. It's a screenshot from the actual product, right? If you can pay attention to this, a couple of things, right? On the left side panel, you see a view all the way from business journeys into pages, into business transaction, to services, down to workloads and pods. And what this talks about is exactly this, right? Instead of looking at multiple tools for each of these insights, right now you're in a position where a user is able to come in based on the right RBAC, be able to get the overall business context in context of the end user experience and the application performance. And very simply, just with that one view, you understand what is healthy and what's not, and you are able to deep dive into specific areas for you to be able to troubleshoot. Right? Compare this with having to go from one tool to another just to find the information of what is healthy and what is not healthy. Right? So that's the difference in some ways. So it's a holistic view all the way from the top to the bottom. Right? Second, in terms of performance optimization, you can get an ability to analyze the performance and the dependency map of the different things. Right? What you see on the right, for example, is this idea of showing the dependency map of the different services and how they correlate to each other. So you are able to do service-to-service correlation, but you're also able to do service-to-infrastructure correlation. It's a very useful example. I was talking to one of the customers earlier in the week, and when I showed them this, there was a big aha moment for them. The reason was their application development teams were being asked to use Kubernetes pretty extensively because it was a mandate. But many of them were not deeply familiar with Kubernetes. They knew how to spin up a cluster, but they did not know how to troubleshoot with Kubernetes, right? That was a real problem. In this particular thing, as soon as I showed it to them, they're like, this is super powerful because every time today I have an issue, I suspect that there is a Kubernetes issue. I need to go Slack someone saying, hey, could you go look into this? Is this really a problem? And then they need to Slack back with me and we go back and forth. In this way, I actually get a view. And if my organization allows me, I would literally deploy this tool, not only for my team, but also for the Kubernetes team, so that if nothing else, when next time there is an issue, we both are looking at the same thing and we know that there is an issue or not. That entire Slack message gets eliminated. And more importantly, the time it takes to bring everybody together to figure out what the root cause is gets eliminated. And that was extremely powerful, right? Suddenly, you have effectively up-leveled the knowledge of somebody who's siloed in their domain, but can get an end-to-end view. They don't need to be experts in the other domain, but they know enough to be able to intelligently troubleshoot the overall issue. That's the power of what we're trying to show here in terms of contextual relationships. Right? The last part that I'll kind of talk about is this idea of how this sets us up for what we talk about in cross-melt. Right? With cross-melt, you can, each of the different data types in some ways allow you to ask different styles of questions. Right? When you look at metrics data, it typically gives you metrics, things like average response time, calls per minute, errors per minute. Right? This tell you very clearly what the problem is. Right? That's extremely valuable because that's what you want to get to first. Right? When you get that alert at 2 a.m., you want to get to the what really, really, really quickly. But the next part, of course, is you need to be able to remediate it. And that's where the where and the why comes in. So traces and events allow you to figure out which part, right? Is it a Kubernetes event, which tells me a pod is failing? Then that tells me where the problem is. Or within a trace and span, I can actually go down the specific code snippet where there's a problem, or there's a Java heap error. That's where the where focus gets focused, right? You know the part of your stack where there is a problem. And lastly, when you get the information details about why that's occurring, right? What's the history, especially if you can look at historical data, then logs give you that answer. So being able to bring insights from all of this into one view helps, again, solve that RCA very, very efficiently. Again, think about current state in some ways. We still ask all of these questions as DevOps people or SRE folks, but we are forced to ask these questions of very, very independent tools and do what I call as human correlation. And what do people end up doing? They do a few things. Either they import a bunch of this data into Excel spreadsheets or Google Drive sheets and start correlating using that. Or if you're a little bit more sophisticated, you bring all of that information into like a Tableau and try to visualize it. If you're even more sophisticated, you put a Grafana dashboard on top and start trying to bring all of this together. But at every point of time, you are relying on the human to pick and choose those parts of data that are relevant from each of these tools and bringing that. So in some ways, your ability as an organization to troubleshoot is a direct effect of how clear and clever that person is who's building those dashboards and the capabilities that Grafana dashboards give you. Right? That's kind of current state. Instead, if we are able to bring all of the cross-melt data in, we can do interesting things, right? First, we'll be able to get the visualization and insights, but then it can get really, really interesting. You can start observing patterns. So you observe log patterns, and that tells you a story about why a certain issue is occurring and what is the periodicity by which it's occurring. So you can actually give feedback to your developers of how they could restructure the code to make things better. Right? You might not even know that there is an issue. So we call this the unknown exploration, right? The same kind of issues have been happening every so often, periodically, right? Every Saturday morning, you see a certain spike that's happening for the last few weeks. It's not clear what happened. With something like this, you can actually take a look at what happened all the way from, was there a new code push in that period of time? Was there a change at the infrastructure level that happened at that period of time? Or was there actually something just as a config change that happened? And how can you roll back in order to bring it to a good state, right? It allows you to ask these questions where you don't even know what the question is until you actually see that there is a problem. And we call this the unknown unknowns exploration. And that's what cross-melt troubleshooting allows you to do. Right? And the last bit, cross-melt troubleshooting almost acts as a layer, right? It acts as the basis by which all of the things that I just mentioned is about what humans could do. Right? As humans, we could ask questions. As humans, we could go deeper and focus on RCA and figure out where the problem is and help remediate it. Of course, at cloud native scale, running it as human operations does not work really, really well. Right? You need to be able to run it such that you can use AI and ML to assist that expansion, to make it faster, to make it more useful, right? And that's what AIOps capability here allows us to do, right? It effectively allows anomaly detection at every layer of the stack. Very simplistically, we actually think about anomaly detection can be extremely complex, but we think of anomaly detection in a very layered approach, right? The simplest way of anomaly detection in some ways is based on metrics data, go look at the fact that there is some behavior that's different from what is normally observed at the metrics level, but also do the same thing at the logs and events level and be able to correlate that using health violation. So if you take a look at the picture on the right, you still have the context of where you are in the stack, right? In this particular case, we can see that the business transaction has an issue based on the fact that there are service and service instances. It shows you the actual service and delivers a couple of suspected causes. And in that time frame, you can actually focus on which of the areas are getting impacted, whether it is CPU usage, whether it is events, whether it is PVC, and so on and so forth. So it gives you a clue not only on what the anomaly is, what could be some of the reasons that are happening, but also some of the metrics that could be violating as part of that anomaly detection. So the system does the hard work for us, which is awesome, right? We as humans don't need to go tool to tool into troubleshooting, but anomaly detection does that for you. More importantly, today, we definitely hear a lot of this from our users where it's easy to get flooded with alerts, right? The alert noise is a huge issue, right? You get a series of alerts. You don't know which one to react to. You don't know how to prioritize. So being able to correlate all of these alerts into an incident. And the reason we can do that is, as you can see, it's an entity-centric model. So if we know the entire dependency of any specific entity, so alerts coming from the different service instances or infrastructure instances, which are all dependent on each other, can be correlated into an incident, and then they can also be correlated by time. So they're both entity correlated and time correlated. Then it allows us to say that that's actually a single incident. It's really one thing that's causing this flood of alerts, and that allows the users to react and prioritize. The next bit that we are working on is this idea of helping users do so using the business impact. So if you're able to answer the question that all of these alerts are part of the same incident, and this is the rank of an incident, because this is the impact to ARR, or this is the impact to number of users dropping off, or this is the impact to the amount of usage of the particular product, or amount of data that's coming into the website. All of those are critical business metrics that customers can define for managing their own business. Being able to correlate performance data to that kind of impact ensures that when they start reacting in terms of troubleshooting, they do so in context of business impact. And at this point in time, business impact is not just a CIO concern, right? We have boiled that down and democratized that so that the people on the ground, the SREs, actually are able to make decisions based on business impact. So the next time when the CIO asks for a report, they can actually have a conversation based not just on saying, hey, look, we had all of these different incidents in this month. This is how we are reacting to it here. Give us some extra amount of money to put in more servers or buy more cloud expense, right? That's a problem that we all face. It's a very different conversation where you say, hey, look, here are the different incidents that we have had. This is the business impact that's had in the last couple of quarters. This is why we need to increase our investment. Very different conversation, very different language that you can effectively start talking about. So that's kind of the power of bringing AIOps, but in context of business impact that we're looking at.
Question?
Yeah, right.
Do you have a sense of the timeline for when organizations start to trust what's being generated by the ML, by the models?
That's a really, really good question. So this is something that I've been actively working with our customers, at least for the last 18 months or so. What I find is as follows, right? Compared to about 18 months ago, there is definitely greater trust in ability of AI to be able to do what I call as reactive troubleshooting, right? When the incident occurs, being able to see something together as an incident is something that customers have become a lot more comfortable now. Even about 18 months ago, when we looked at our own anomaly detection option, overwhelmingly people tended to use kind of manual health rules because the idea was, hey, I might just miss that, right? And they would complain a lot about the fact that it's a very noisy system. But then I would go out and talk to them, okay, look at the number of health rules you have. You have 500 health rules. How do you expect it not to be noisy? But their entire thing is, I can handle the noise, but if I miss something important, I'm going to lose my job. So can't do that. So that idea of when there is a problem, I will get the right alert from anomaly detection. I think that level of comfort and confidence has come into the organization. Where the CIOs are pushing them is, hey, can we get to predictive alerting? Can we get to a situation where, based on what you're seeing, you can tell us what could be the problem, not next year, but in the next couple of days, so that we can be proactive. And this becomes even more important during the Black Friday kind of deal, right? Where you want to be prepared rather than just over provision. For that, I think the practitioners are still very much in like, can I really trust AI for that? So they still prefer a lot more heuristics rather than actually AI. So work in progress. I fully expect that in the next 2-3 years that will actually change. But that's kind of where the industry is right now.
Okay. And is the machine learning being done specifically on an individual customer's logs, events, and alerts and so on? Or are you also able to look at kind of a lake of anonymized data across customers and industries?
Yeah, that's the only way to do it, right? In some ways, the machine learning has to be done cross tenants. The insights are very specific to a tenant, right? What we give as insights, but the learning happens on kind of the data lake across the board, and that's the only way to make it super effective.
Okay, so I, as a customer, then have to probably sign in to say, yes, you can bring my data into your learning cloud.
So yes, so customers typically agree to get that information in for learning data, but no PID. The good part about the observability market is typically there's not a whole lot of personally identifiable information. Sometimes there is, but a large majority of it, it's not personally identifiable, which is why they are more comfortable with being able to aggregate. There are other use cases that have been in the past, like stuff like life sciences, where it's a much bigger problem. So I spoke a bunch. Let me try to show you a demo. So let me try to contextualize what you're seeing. The product, as we launched it yesterday, we're going to have the first GA by the end of this month. And let me talk to you about the specific use cases that we're targeting for the GA release. Right? The first use case is really about helping customers who have public cloud environments, who have OpenTelemetry-based instrumented applications that are hosted on AWS or Azure Kubernetes-based environments. Right? That's really the target use case for us, and then we'll build over on tops of the different use cases. The couple of nuggets of value that I want to talk about is this idea of what I talked about, cross-domain insights and cross-melt troubleshooting. Those are the two big kind of nuggets of value that we will deliver for troubleshooting as part of this GA. What you'll see in this demo is, think of it as because it's a fictional company, think of it as a Acme Corp, who are actually fairly mature. They're cloud native. They have their entire applications in AWS EKS. And they are an e-commerce company, which also has a display ads business. And the marketing department has come in and talked to the DevOps team saying that, hey, the ads are not showing up. There is a problem with it. There's an impact on ARR. So we're living the life of Aparna, their DevOps person, who's basically on charge to go fix this issue immediately. Right? Like, I need to do this because it has an impact on ARR. So with that, so let's say she logs into AppDynamics Cloud. And this is the first initial view that she gets. The good part about this, it's a very simple, very minimalistic view, but gives a very bird's eye view of our entire environment. As you can see, she can see the entire service layer. Yeah. She can see the Kubernetes and the infrastructure layer as part of it. She notices that one of the services actually has a health status issue. And she also sees that the underlying Kubernetes workload also has an issue. So that gives her a clue. So she double clicks into the service to figure out what the problem is. Right? And she sees the view that I kind of showed earlier in the presentation, where from the left side, she can get that entire view all the way from the business transaction. And she sees that the get ads business transaction is having a problem and the ad service is down, right? That gives the clue. It correlates with the problem that she heard from marketing. Now she needs to find out what exactly, right? Where is the problem? She notices that the average response time, as you can see, has spiked up. So that gives her a clue that there is an impact on the service instance, and the fact that there is a red on the workload means there is a problem at the Kubernetes layer. Right? So she logs in and tries to find a little bit more details. Right? She's got a metrics-based view. She's got that bird's eye view. She knows where the context is between service and service infra. And she starts looking at logs. Logs data look normal. She starts looking at the Kubernetes events, and she can see that there are a few severe events, and there are a few warning events, and they are correlated to the health violations that we see on top. Right? So she wants to dig a little bit deeper. She looks at the event. She notices a bunch of warning. And when she double clicks, she sees that there is a backoff event. That's the clue, right? When she's seeing a backoff event, she knows that that could be an impact on the Kubernetes pods. And she looks down and she finds that there are some times that the pods are failing and they have had to restart. So that gives her a clue that, hey, this is a problem of the fact that it's happening at the Kubernetes layer, which is causing pod restarts, right? Now, she needs to figure out what the issue is and why this is happening, right? So our next step is to investigate on the metric side of the house and she starts looking at the CPU usage, the memory usage, and the limits across. And what she notices is, if you can see, the memory usage has frequently spiked above 100%. And that gives the clue, right? The pods are not able to restart whenever there's a spike up, and that's a problem. So offline, she has to go talk to her dev team. She realizes that there's been a canary release of the code and configuration earlier in the week, and that has changed the config. And as a result, memory is under provision. So she has to go talk to them, redeploy a config, roll back the change to ensure that at least the immediate problem gets fixed. And once she does that, she's able to bring the entire system to good state.
So I got a question about that, because if I've implemented alongside with real user monitoring, right?
Yep.
I've got the alert before this reaches any internal team. Wouldn't I just then jump to the app dev team and tell them to roll back?
Absolutely. So in this particular scenario, I had not played it where the real user monitoring was deployed, but absolutely. If that ability was there, you would absolutely do it. But even then, you would still need to know why you would have to roll back. So you would still take these steps. The entry point would be different. Instead of the marketing team coming and talking to her about it, it very much would have been on the dashboard. You would see that there is an issue on the response time, and that would trigger this entire investigation. The rollback, again, in this particular case, it turned out to be a code and config change. Imagine a different scenario where it was actually not a code issue or a config issue at all. It was the underlying infrastructure was having a problem, or they were hosted in AWS. It was actually an AWS issue. All of those are possibilities. So the investigation would be very, very similar. But yes, the entry trigger point could be very different at that point. Yeah.
And it would trigger a different workflow, is what you're saying, right?
Absolutely.
It depends on how we're determining what the issue is, right?
Absolutely. You got it. Actually, that's a nice jump off point. The good part about it is, in some ways, the product is minimalistic in some ways by reason, because we want to be able to give an opinionated workflow, but bring the information together so that when these different troubleshooting workflows happen, customers can kind of self-choose their journey of what's the fastest way to get to the truth and be able to remediate that.
And that wouldn't that even mean different teams, right?
Absolutely.
Different people, different teams, just depending on how the company's built the app around it.
Absolutely, absolutely. Using RBAC, they can customize the views that they care about of what their department is, and more importantly. But what we're finding based on this is, as we go out and talk to customers, they all seem to have recognized the need for almost like not a central, but an observability team, which has the ability to look across and look at the entire environment. Because when they get into those knotty issues where it's not clear which part of the stack or which team is a problem, they want to almost have like this observability czar, for the lack of a better word. Seems like a fairly new practice that we are seeing, but that's one of the things that we are observing among customers.
And you said, did you say you see that as like a new team or department being built at customers, like observability for everything?
It's I don't know whether it'll become an entire new team. It's a lot of the same humans that are being tasked with this.
Right.
Whether it'll go in and build an entire new team is still TBD.
Kind of like instead of having observability person in each team, network guy, server guy, infrastructure, et cetera, just pull them all together
and bring an observability team together. So we'll see if that works.